Welcome, Calculus AB. This is on section 6.1 slope fields. Let's begin. So just a reminder, we've talked about differential equations before, and this is when an equation involves x, y, and derivatives of y, like y prime or y double prime. So for example, 2xy prime minus 3y equals 0. This is a differential equation. Now, we can find a solution of an equation, so like a y equals whatever is a solution if when you substitute it in, the equation works out. So let's do an example of that. I have this equation right here, y prime plus 2y equals 0. And y equals e to the negative 2x is a solution. And here's how I'll prove this. If y equals e to the negative 2x, that means y prime equals the derivative of that, which will be negative 2 e to the negative 2x. I'm going to substitute that in. So substituting in for y prime, you are going to substitute in negative 2 e to the negative 2x, and then plus 2 times regular y, which is e to the negative 2x, equals 0. Well, those are just opposites of each other, so negative 2 of those, positive 2 is 0 equals 0, so it checks out. This y equals e to the negative 2x is a solution. We can also come up with something called a general solution. When we have a general solution, it means there's a constant in front, like c times e to the negative 2x. So sometimes that means c could be any number. So this will be called a general solution. And in some cases, we only have a singular solution. That means there's only one possibility. C can only equal one thing, or there's no generic C can't just equal anything. So actually, let's take that last example here. There is a general solution of y equals c to the negative 2x. I'm going to show you. So if you plugged in, instead of using this equation, let's use this one, and y prime would be, in this case, negative 2c e to the negative 2x. If you substituted that in, you'd get y prime negative 2c e to the negative 2x plus 2 times c e to the negative 2x equals 0. And yeah, those parentheses don't matter, plus 2c e to the negative 2x. Again, they would cancel each out, negative 2c e to the negative 2x and positive 2 to the negative 2x. So 0 equals 0, and that checks out. So this is a general solution to that equation, and this was a particular solution for using words we've done before. Alright, so let's take this example here. Determine whether the function is a solution to this differential equation, y double prime minus y equals 0. Cool, so I'm going to do all three of these. Well, if y equals sine of x, y single prime equals cosine of x, and y double prime, because that's what we need, is negative sine of x. So substituting that in, I get negative sine of x minus sine of x equals 0. What? That is not a solution. Yes, we have to determine. So negative 2 sine of x equals 0. We say nope. That does not equal 0. Alright, let's try next one. B. So if that's y prime is going to be negative 4 e to the negative x, and y double prime is going to be, oh, yeah, I'm right on. Yep, and y double prime is going to be 4 e to the negative x. So I'll substitute in. So I'll substitute in 4 e to the negative x minus regular y, 4 e to the negative x equals 0. 4 minus 4 is 0 equals 0. So we say yes, that is a solution. Part C. So I'm going to say y prime is going to equal c e to the x, and y double prime equals c e to the x. So then our case is going to be c e to the x minus c e to the x equals 0. 0 equals 0. That is going to be another yes. So no, yes, yes. Alright. So we also might want to find a particular solution. So instead of verifying things, I want to figure out that solution. So if we have a differential equation, xy prime minus 3y equals 0, verify that y, it's a two-parter here, verify that that is a solution, then find the particular solution. Oh, I shouldn't have kept the solutions in there. Then find that particular solution where by the initial condition y equals 2 and x equals negative 3. Pretend you didn't see that. So first I want to verify that this is a solution right here. And so I'm going to type in, let's see, can you read this? Oh boy, that's not going to work. Well, you're going to wait. This is going to be awkward. I'm not going to edit the video though. There we go. Okay, let's do it my way. So if my y equals cx cubed that means my y prime, I'm going to need that, equals 3cx squared. I'm going to plug that in. So if I'm substituting that in, I get x times y, so x times cx cubed. Oh no, it's y prime. Oops. X times 3cx squared minus 3 times y, so cx cubed equals 0. Substituting that x in, or combining them, 3cx cubed minus 3, get rid of parentheses, cx cubed equals 0, 0 equals 0, and so, yep, it works out. First part. Then find that particular solution. So to find a particular solution, if this is the general, that means I got to figure out what does c equal. So I have this equation, y equals cx cubed. Let's substitute in 2 for y and negative 3 for c. So I get 2 equals c negative 3 cubed. So 2 equals c times 27, or 27c, or negative 27c. And so then your c in this case is going to equal negative 2 27ths. Alright, so our particular solution is, if that's the general, I just substitute in something else for my c, and I write y equals negative 2 27ths x cubed. There's my particular. Alright, another thing we're going to talk about, slope fields. So this is new, and this is going to show up a lot. So sometimes it's hard to find those solve for a differential equation. Those don't always work out. But we can figure out the shape using a slope field. So a slope field is basically, instead of just plotting a bunch of points, like what the equation is, like or all the points in a function, basically at every point on the graph, we plot what the slope would be. And these are what these slope fields are going to look like. A bunch of lines at each point, not dots everywhere, lines. And these lines represent slopes. So I have this case, and they can look like all different shapes. Now, so the details. How do you create a slope field? You draw short line segments at points that are the slope at that point. So for example, if we took in that last case, if you look at this problem right here, this is an equation that dy dx equals y. So at 0, 0 right here, your slope is just a flat line, and that's going to be a slope of 0. And when you do all these slope lines, you can create a general shape. So you might see, like you're looking at the last one, you see kind of a shape going like this, or you might see shapes going like this in this graph, or kind of doing this thing on this graph. So you can draw a general shape of all the solutions for the equations. So this one looks like sine waves or cosine waves. This kind of looks like a sort of parabola. I think it's a higher order polynomial. And you got this shape going on here. Okay, so let's actually sketch a slope field. This is going to be a simple one of those for now. So sketch a slope field for the differential equation y prime equals x minus y. So for these points, that point, and this point. So in your slopes, every point you plot is basically going to be your y prime, because that equals your slope at that particular point. So let's make a table going on here. So here's my point, and then we're going to make what is the slope going to be. So if I have my first point, negative 1, 1, well, if you plug in negative 1 for x and 1 for y, you get negative 1 minus 1, negative 1 minus 1, which will be negative 2. Okay, next point, 0, 1. You're going to plug in, you're going to get 0 minus 1, which will be negative 1. And last point, 1, 1, you will get 1 minus 1, which is 0. So plotting those points, the first point, negative 1, positive 1, we're going to call that right here. So instead of putting a dot there, which we'd usually do if we were plotting that point, I'm actually going to do a slope. And the slope of a negative 2 is going to look roughly like this. Okay, next point, 0, 1 is going to be right here. It could be a negative 1 slope. That's not going to be as steep of a slope. It's almost like a diagonal. Like that wasn't really that great. There you go. So it's not as steep of a slope. And last one is point 1, 1 and slope of 0. Slope of 0 is a horizontal line. So it'll look like that. So you see it's a steep slope, but then that should have been horizontal. You know what? I'm going to use a real line. Yeah, that looks a lot better. Yeah. There we go. So there's my slope field. I only did 3 points. That's it.